Hey guys, this recording is for our class on February 2nd, 2021, my Tuesday morning class and my Tuesday evening class. If this is my Saturday class listening in, the date is much later for you. Don't worry about that. Still the same information that you'll need for this section of your classwork. Okay, so I'm trying to make this video less than an hour, but first I must apologize for getting this video out so late. I really need to work on timing and getting out these videos and the worksheets earlier to you, especially the class that begins at 9 a.m. on Tuesday morning and Thursdays. All right, so to get straight into it, this is the warm-up that we're going to do on Tuesday. We'll do a few of these problems, starting with the first one, okay? So with the first one, let me make some space here. Here we go. Now I have this. Remember, with dividing fractions, I have -9/5. I'm going to keep the first one, right? Changing this into a fraction. And now I'll keep the first one the same, change multiplication, and flip. And then I don't see anything I can reduce. Nothing is going to reduce this way, right? Nothing is going to reduce this way. I already know that for sure. And then I'm going to multiply straight across. I have -9 times 1. That gives me -9. And then I have 5 times 2. That's going to give me 10. So that is my final answer, -9/10. I do want to point out something though. A lot of times people get confused about what to call this fraction because of the negative right here. And let me tell you, it does not matter where the negative sign is, right? See, I put it up here and I said -9/10. It does not matter if the negative sign was there, or if it was here in the middle, or even if it was down here at the bottom. The whole fraction is still negative. So -9/10, no matter where you see that negative sign. Okay? Hope that helps. Alright, so now I'm going to go over and let's do the last one on this first line here. Take some space down here. Here we go. And what do we got going on? Aha! First thing I'm going to do is change that to a fraction, right? And then I'm going to change this into an improper fraction. 3 times 5 is 15, plus 4, 15, 16, 17, 18, 19. That gives me 19/5. Negative divided by -2/1. I'm going to keep the first one the same, -2/1. Change multiplication and flip. There we go. I can tell you right now, nothing is going to reduce. So I'll multiply straight across. It's going to be -10/19 for that final answer. Let me go down here and do number 4. That way you can do that last one on your own. But I'm sure we'll do it tomorrow during warm-up time anyway. Okay, so for this last one, let me create some space. Here we go. I'm going to change the first one into an improper. 7 times 4, I think is 28. You know me? Not too sure. 7 times 4. Hey, look at that. I might finally have that memorized. 7 times 4 is 28, plus 2, 28, 29, 30. So I got 30/7, right? I'm going to change this multiplication and flip. There we go. Notice I can cancel these out. And I can also cancel out the 30 and a 6. They're both even numbers, so I'm going to divide by 2. 2 will go into 6 3 times. 2 will go into 30. Let's have 30. 15. I can reduce again that 3 and that 15. Notice I can reduce that again. They're multiples of 3. 3 will go into itself 1 time. 3 goes into 15 5 times. There we go. Now I'll multiply straight across. 5 times 1 is 5. 1 times 1 is 1. Now, of course, I could just keep it as at 5, right? Meaning I could take this out right here, just keep it as 5, but I'm not going to do that because I still have more fraction to work with, right? So what I'm going to do now is, meaning I've taken care of this, so I need to bring down the rest of it, which is times 5/8, right? I do not flip. I don't flip because it's already multiplication. Already multiplication means I don't have to flip. I'll look, though, to see if I can reduce. And I will tell you, we can't reduce anywhere. So we're going to change this to 5 times 5 is 25. 8 times 1 is 8, but you know you can't leave it like that. So let's do our division. 8 will go into 25 3 times. Because 8 times 3 is 24, right? Hopefully I'm doing this right. And that means my final answer will be 3 and 1 over 8. Okay. So let's practice one of the ones down below that are probably freaking you out. Okay, so number 1. Remember, this is where the variables are already given to you, so that's why I like to call this part evaluating, which means solving, given variables. Given variables means that I've already gave the variables to you. So variables are the letters. So I'm already telling you what the letters equal. So you just have to substitute them in to the problem. I'm going to rewrite it down here, and I'm going to substitute the numbers for the letters, because I can see that x is going to be 4, and then u is going to be 6. So I'm going to rewrite it using 4 and 6 instead of x and u. So I have u, which is 6, minus u, which is 6, divided by 8 minus x, which is 4, those parentheses. You see, that's a big set of parentheses here, times 7 minus u. All right, I meant, not put the u, I'm going to put 6. So times 7 minus 6. As you can see, order of operations, we're going to start here. That's 4. All right, let's bring down everything else. We have this. Okay, now, order of operations says that we are going to do this next. Now, 6 divided by 4, you know, we're supposed to do it by hand. If we do it by hand, we're going to get, well, I can show you. 4 divided by 6, right? You know it's only going to go in one time. 4 minus 6 is 2. Put a decimal, right? Add the 20. Or added 0, so you get 20. Now it's 4 goes into 20. That's 5. 5 times 4 is 20. 0. So this is going to be 1.5. If you weren't sure how to do that, let me erase this part over here so I have my space. Okay, so now that's 1.5. Remember, you still have to bring down the rest. Took care of that. So now it's 6 minus 1.5. 6 minus 1.5. I'm going to fill in with a 0. Makes it easier for you, right? I'm actually just going to do it in a calculator. 6 minus 1.5. That gives me 4.5. Here we go. Right? So now I know that this is actually all 4.5 down here. Okay? I could have done it without the calculator too, because you're supposed to be able to do it without a calculator, so here we go. 4.5. Just wanted to prove myself to you. So basically what we have done now is everything that's here. Let's bring down the rest. Times 7 minus 6. According to order of operations, you know we're going to do this next. And long story short, I will tell you that's 31.5, right, minus 6. That's going to give us, long story short, 25.5 as our final answer here. That one was the most difficult one for that type of problem. So let's try another one. And then, of course, we do the rest in the class. I'm going to go down here to number 2 and see if I can fit everything on this last part of the page. B plus 3 plus 2 minus Z plus 8 minus B. Let's rewrite. B is 8, Z is 1. So I have 8 plus 3 plus 2 minus 1 plus 8 minus 8. Now, notice this is all adding and subtracting, so we're just going to start from the beginning. 8 plus 3, 8, 9, 10, 11. 11 plus 2 Gives me 13 minus 1 plus 8 minus 8. Next would be 13 minus 1, which is 12, plus 8 minus 8. Okay? I'm just going to go this way. 12 plus 8, 8, 12, 13, 14, 15, 16, 17, 18, 19, 20. I knew that was 20. So that's 20. Takes care of this. Minus 8. I can't do that. 20 minus 8, 12. So final answer here, 12. Here we go. Okay, so I'm going to be done with that page because there's plenty of stuff left to do for this video. Okay, now let's see what we have left. Okay, classwork part 2. These are combining like terms, right? And this should be a review right here. So I'll do a few of them. One thing that I want to make sure that you know is that when we're combining like terms mean, do they have the same letter? Or do they not have letters? Those are like terms. I like to call them family members, right? Family members must match. X's with X's, right? Or no letters with no letters. You get the idea. Okay, so now here's what I got. Let's take a look at number 1. The reason why number 1 is important is I want to make sure that everyone realizes that when you see a letter by itself, it really has an invisible 1 in front of it. So make that invisible 1 show up. This now reads 3x plus 1x. All right, let's add them together. 3x plus 1x is going to give us 4x. Nothing else you can do with that? You're done. Okay, let's try one that's below. Number 5 gets a little bit longer. We're going to combine the like terms. I see a negative 3n and a positive 6n. Negative and a positive, I will subtract, keep the sign of the higher digit, which is the 6n. Now, if you're not sure how I got 3n out of that, you need to go back and look at those integer rules. Okay? That's going to be a common theme throughout the next, 12 classes we have left. 10, 9, 8, whatever. Okay? Now I'm going to look to see if there's any other like terms I can combine, which I can see here, and I can see here. All right, so I have a 7 plus a negative 2 combined with a negative 2. Subtract, keep the sign of the higher digit. My answer is 5. So my final answer is 3n plus 5. Remember, you cannot try to combine these because they are non-matching family members. This has an n, this doesn't, so you cannot combine them. They're not from the same family. Okay, so again, final answer is going to be 3n plus 5. That's all you can do with that one. Oops. All right, so, oops. I'm going to go back and do number 6. Let's see, move the screen back to where it was. Sorry about that glitch. All right, looking at number 6. So number 6, I'm going to see what terms I can combine. I have an 8t with a negative 5t, right? 8 plus negative 5 is going to give me a positive 3t. Again, if you don't understand where that came from, we need to take a look at integer rules, please. That means I've taken care of this, taken care of this. All right. I still have like terms, a negative 20 and a negative 5. Negative plus negative, my answer is going to be negative, just add, integer rule. These two are not like families, so that's the last I can do with that. So the final answer for here is going to be 3t minus 25. Okay, let's take a look if there's another one that we should do. Okay, you see number 10, I'm going to save that for later. And the rest of these I'm going to save for later too, because there's a lot on this sheet right here. All right, distributive property. Do a few quick these because we should know what it's like already. All right, here we go. For number 11, I'm first going to distribute. Remember, this is distributive property and combining like terms, which means we have to distribute first. I have 3 times y, that's going to give me 3y. And 3 times a positive 2 is going to give me positive 6. And outside the parentheses, I'm just going to bring down that 6y. So now I can combine like terms. As you can see, you have y family members. Those are both positive. We're going to add them together. 3 plus 6 is going to give us 9y. And notice This regular plus 6, I can't do anything with, so I'll bring it back down, leaving 9y plus 6 as my final answer. All right, let's try another. Here we go. Let's do, okay, sure. We can do negative 8z. Negative 8z is going to give me, negative 8 times z is going to give me negative 8z. Negative 8 times a positive 1, negative 8. And then I have positive 2 times z. It's going to give me 2z. 2 times 4, it's going to give me a positive 8. Combining like terms, I'll start with the z's. I have negative 8 combined with a positive 2. That's going to give me a negative 6. Negative 6z. Right? I combine other terms. I have a negative 8 and a positive 8. We know now that a negative and a positive of the same number is just basically going to cancel out. Okay? So we don't have to write anything left because this will be our final answer, which is negative z. Alright, so you might be looking at these and freaking out, especially when you have something that has 2 letters with it. Don't worry about those. The rest of these are exactly what we just practiced, okay? The only thing that's a little different, and if you were in class last time, you would know that when you're distributing, right, when you have no number in the front, but you have either a negative sign or just a letter, you're going to make that visible 1 pop up, okay? So basically this is negative 1x, right? And you're going to multiply it with y. That's going to give you negative 1x, y. And negative 1x times a positive 4 would give you a negative 4x. That's my clue to that one, and you could actually finish out the rest, combine your like terms, and you would be done. Okay, so we'll do that one in class, though, don't worry. Lots of other stuff to get to. All right, so here, let's try looking at part 3. Part 3 says, first simplify the expression, then evaluate when x is 3 and y is 4. Okay, so first simplify means that we're going to combine like terms, right? So let's take a look at the first one. You see you have a 3x and a 6x. If we combine those, we have 9x. Nothing else is going to combine with that 2y, so let's bring this back down. And now it says we need to do this. X is 3 and y is 4. So this really looks like 9 times 3 plus 2 times 4. Order of operation, 9 times 3, 27, plus 2 times 4, 8. 27 plus 8, which you know I don't have a single clue, 27. 27 plus 8, 35. Final answer for that, 35. There you go. That should make doing 18 and 19 easier. So remember, combine first, plug in your numbers, solve order of operations style. Let's see what else is on this page. Okay, part 3 continued. You still have more of the same thing, okay? So, let's take a look at number 22, though. Let's do that one, just for kicks. Move my calculator over here. Move myself over here. Here we go. First, we distribute. X times y is xy. X times a positive 4 is 4x, or x4, but it looks better with keeping the number first. 3 times 2, positive 6x. 3 times 7, positive 21y. Assuming I did all my multiplication right. So now, first thing we're going to do is combine the like terms that we have. Okay, so we have xy. Note, this is a term, but there's no other xy family members here. All the other family members are just x or just y, right? So we're not going to do anything with that. So that one's going to stay by itself. I'll keep it as beginning half of my answer. And then, let's see, what else could I combine? I have my x's. Good at my boyfriends or something. Okay, so 4x plus 6x is going to give me 6, 7, 8, 9, 10. That's a positive 10x. Done. And then, lastly, I have my y's. I only have one y left here, so I'm going to bring that down, 21y. Now here's the thing. We're still not done because we now have to plug in the values that we have for the letters. Remember, x is 3 and y is 4. Okay, so this means I'm going to rewrite this. If x is 3, whoops, I have 3 times y plus 10x plus 21y. Order of operations, we do the multiplication first. That's 12 plus, that's 30, plus 21 times 4, no idea, 21 times 4, that's going to be 84. We then add all these together, which I'm just going to do by calculator. So you have the 12, make my calculator bigger. Jesus. Alright, that helps. It doesn't. 12 plus 30 plus 84. Total answer here, if I did it right, it should be 126. There it is. Okay. Number 23 I just threw in there because it's actually a geometry problem, and we can go through that one in class. Alright, so that takes care of classwork number 1. I will give you, okay, I just got to give you a clue, okay? You know now that x is 4, so plug in 4 everywhere we see x. And then what you're going to do is just add up all of these together to get to perimeter. Perimeter means the amount of length all the way around the shape. So it would be this side plus this side plus this side plus this side, okay? And then that would be your answer to that. And it then means, if you're able to solve it, that you just did a step of geometry, which comes after Algebra 1. Alright, let's see what else is next. Oh yes, oh these, let's see, classwork 2, that's kind of like the work that we just did, okay? So, basically, and it looks like the couple of problems we did in the warm-up review I just had, and so remember, with these, the semicolon is where the question ends, okay? And then it tells you what x equals and what y equals. So if I rewrite this, y divided by 2 plus x, it would look like 2 divided by 2 plus 1, because I'm plugging in the numbers here, right? Do this order of operation style. 2 divided by 2 is 1. Bring down your rest. 1 plus 1. Final answer here is 2. Let's practice a few more of those that are the harder ones. Let me take a look around and see what we got. How about number 12? Here we go. Alright, number 12. I'm going to rewrite it knowing that y is 10 and z is 2. So it says y, 10, minus z, 2, plus z squared. That's not as bad as we thought it was going to be, is it? So according to the order of operations, you know this is going to be first. 2 times 2 is 4. Plus 2, that's going to give us 6. Bam, took care of the parentheses part. 10 minus 6, 4. That was nowhere near as hard as I thought it was going to be. We're going to move on. Okay, so moving on, let me double take a look. Number 13 we'll do in class. That looks a little bit weird, doesn't it? But let's move on. We did, there we go, here. Actually, let's go ahead and do number 13. Remember order of operations style, so here we go. What we have is z. Z is now 7. 7 minus y, which is 3, divided by 3 minus 1. Oh, good, okay. So, you know you're going to go to this first. 1. 1 minus 1, that's 0. Bring down what was left. 7 minus 0, 7. Right? You've done way harder problems than this, right? Alright, y'all got that. Okay, let's move on to what else we have. Oh yes, going back to one-step equations. Here we go. Okay, now for video's sake, I'm not going to review the one-step equations because I already did that in last week's video. Let me just point out where that would be. So these are one-step. So here, just want to make sure everybody knows these are one-step equations. The video for this is already posted on how to do these types of problems, right? I'm not sure if the same type of problems or same exact problems, but they should be or might be. Let's take a look. Yeah, I think they are. Let's take a look at the video I already recorded for a second. Okay, so last work stuff. When you get here, the work I'm posting today is going to already be there. So if we have the one-step equations, which this might be it, so it's already here. See these same type of problems that I'm bringing back to you in class, right? Take a look at there, take a look at here. They're the same problems. So this means there's a video already done. So if you go back to the classwork on the 28th, you'll find a video. It's either going to be in here or it's going to be in here. So I'm not going to re-record that because you can always flip back to that video. All right, so let's see what else we have. Save some time. Those are the one thing I do want to point out, already on video. Let me write that, just in case you're just looking and not actually listening to me. These are already on video. Right here. Right here. Okay? So, there it is. Or, it's going to be this video right here. So here. Or here. There. Same problems. And these are called one-step equations. Right? Add or subtract. Add or subtract, right? Now, what I also put on video are these one-step equations. Right? Let's go check. So for here, and I think that's on part 2, which is right here, should be the same problems. And, oh, look at that. I did the adding and subtracting. Let's take a look at the middle. I should have the multiply and divide video too. Right? And I do. See the 106 or 102 divided by 6x? Make sure that the video is exactly the same. 102 divided by 6x. So the video is there, so you can go and review those. Even for which one of my classes, can't remember if it was evening or morning class, that I did not do these one-step equations, the multiply or divide. So these are one-step equations, multiply or divide. Right? One of the classes I know I didn't do them in, and don't worry, we'll take care of that while actually in class. The other class, this should be extra practice for you, okay? But don't worry, I got everybody. We can handle this. Don't worry about these. You can watch the video ahead of time, except maybe my morning class, which won't have enough time. So let's move on to see what else I have. And, So these are two-step equations. That's what we were going to go next. So remember, with one-step equations, right, you had to do one thing in order to get the letter by itself. With two-step equations, guess what? You're going to have to do two things to get the letter by itself. Okay, so this is where new work actually begins. So we haven't actually practiced these in class. Two-step equations. Again, what I was saying with one-step equations, you do one thing in order to get the letter by itself. With two-step equations, you got to do two things in order to get the letter by itself. And if you've practiced the adding, subtracting one-step equations and the multiplying and dividing one-step equations, two-step equations is just a combination of all of that. Okay? For example, first one, I'm going to rewrite it over here. All right. We still do our same steps. Draw your street. Figure out what side the letter is on. You can see it's on this side. So if you look, we have to get rid of two things in order to get the letter by itself. You got to get rid of this 10, and you got to get rid of this positive 4. Right? We will do adding or subtracting first. Remember, you already know that this means divide. Okay? We don't do the division part first, or multiplication. We don't do division or multiplication first. We always do the adding or subtracting part first when it comes to two-step equations. Okay? So that means I'm going to get rid of the positive 4 first. To do that, I'm going to subtract 4. What I do to one side of the street, I must do to the other. So the r over 10 is still here. That canceled out. Bring down my equal sign. 5 minus 4 is 1. Now what you just did was you turned it into a one-step problem, right? This should look familiar. So, especially the class that did the multiplying and dividing ones, okay? In order to get r by itself, we need to multiply by 10 on both sides. Remember, fractions mean divide. We do the opposite of what we see, which is multiply. Multiply by 10 on this side, multiply by 10 on this side, right? So if I multiply here, first I get to cancel. Remember, 10s will cancel to 1s. I will multiply straight across. 1 times r is r. 1 times 1 is 1. Basically, I can just leave it as r, which was the whole point. Bring down my equal sign. 1 times 10 is 10. R equals 10. We're going to try another one that looks just like that. And that's over here at number 2. Okay, let me write it bigger here in the middle. I have n divided by 2 plus 5 equals 3. Right? I'm going to draw my street. Boom. Always do adding or subtracting first. So that means I'm going to get rid of the 5 first. By subtracting 5. Subtracting 5. Right? And over 2 is still here. That canceled out. 3 minus 5. Don't forget your integer rules. Right? Subtract, keeping the sign of the higher digit. Negative 2. If you notice, n is still not by itself, because you have now reduced it to a one-step problem. You know that n over 2, that means divide, so you'll do the opposite of what you see. So opposite of division is multiplication, and I'm going to multiply that 2. I'm going to multiply that 2. There we go. Now, multiplying 2 with n over 2, you can see this will cancel out. Multiply straight across. 1 times n, Jesus. Multiply straight across. 1 times n is n. 1 times 1 is 1. We really don't need that 1 on the bottom. We have n by itself now, which was the whole point. Do the math on this side, you get negative 4. So final answer for here, n equals negative 4. There we go. Let's try another one that looks a little bit different, and that would be number 3. Let me rewrite that over here. 3p minus 2 equals negative 29. Now this looks a little different because you don't have a fraction, but that's okay. So remember, two-step equations, you do the adding or subtracting first. This is not adding or subtracting because if you recall, a number right next to a letter means multiply. So that's not where we go first. We have to get rid of this first. And you see it's negative 2. So we will add 2 to both sides. Add 2 to both sides. 3p will come back down. That canceled out. Right? Negative 29 plus 2. Subtract. Keep the sign of the higher digit. That's going to give us negative 27. Right? So if you look, p is still not by itself, but you did knock it down to a one-step equation now. So now we divide, because 3p means multiply, so we will now do the opposite of what we see, which is divide. Divide by 3 on that side, divide by 3 on this side. This cancels out, leaving p, and then negative 27 divided by p should be 27, yep, 9. Negative 9. So final answer for this one, p equals negative 9. Let's try another one that looks like a multiplication problem. Let's see, there's a lot of problems on here. Looking for a good multiplication problem to practice, we will do number 20. So, looking at number 20, let me rewrite it over here. I have negative 12r plus 4 equals 100. Here we go. Subtract 4. Remember, do the adding or subtracting first. 100 minus 4. I'm thinking 96, 97, 8, 9, 100. Okay. Whew. That one's actually hard. 96. That canceled out. Negative 12r. I did it backwards, but it doesn't matter. Divide by negative 12. Divide by negative 12. Right? That cancels out. 96 divided by negative 12. That's going to give me negative 8. Final answer, r equals negative 8. Okay? Now, I know that you noticed. Whoops. I know that you could not help but to notice problems that look like number 5. Number 5 has a funky fraction. Remember, we were working with funky fractions. I'm going to do one of these because this video is already 37 minutes long and I got more stuff to do. Alright, so, okay, so let's do number 5. Number 5 looks different than, like, number 7, right? Number 7 has a regular fraction in it, okay? So, with numbers, in fact, let's do number 7 as a review. I have negative 9 plus n over 4 equals negative 7. By now, you know you're going to do adding or subtracting first. This means divide, so you don't get rid of that first. You have to get rid of this first. And we're going to do that by adding 9 to both sides. We do that, this cancels out, leaving us n over 4. And then negative 7 plus 9, we're going to subtract, keep the sign of the higher digit, which is going to be a positive 2, right? So notice it is now a one-step equation. Now we can do this. Fraction means divide. So you'll do the opposite, which is multiply, right? Multiply 4 on both sides. You know these are going to cancel out. 1 times n is n. But we don't need that. 2 times 4 is going to be 8. So n equals 8. So by now you should be used to how to do this type of fraction. With the funky fractions, and this should sound familiar, you have to get rid of what's on, you have to, that's wrong. Let me do it this way. This is how you do it. Okay. So remember I said you have to do multiplying or dividing for, or you have to do adding and subtracting before you can multiply or divide. When it comes to funky fractions, it's the opposite. So again, review, with these type of problems, right, you can't do this first. You have to do this first, right? When it comes to funky fractions, right, you can't do this first because the fraction is in the way. So that means you actually do the fraction part first. So you can see it's k minus 10 divided by 2. Divided by 2. And remember, our job is to do the opposite of what we see. So if we see divided by 2, guess what we're going to do? Correct. We will multiply by 2. So remember, with funky fractions, it's kind of backwards. And I'll explain again in class. Okay? So if I do this, You see the pattern already, right? 1 times k minus 10 is going to give me k minus 10. 1 times 1 is 1. You know the pattern. We don't need that. We bring down our equal sign, right? 7 times negative 2, or negative 7 times 2 gives me negative 14. Now look at what you just did. You just created, right, a one-step equation by doing that. So now you see that k is not by itself, so what are you going to do? You're going to add 10 to both sides. Add 10 to both sides. K equals negative 14 plus 10. We're going to subtract, keep the sign of the higher digit. So k equals negative 4. Let's do that one again, just in case. K minus 10 divided by 2 equals negative 7. Again, it's a funky fraction, right? You have to multiply out that 2 first. Remember, with these types, okay, we would do adding 9 first, okay? So this would have been first if we were doing a regular fraction, but this is a funky fraction. So we have to actually do the multiplying part first. So k minus 10 divided by 2, opposite of divide is multiply. Multiply out that 2. There we go. Doing this, I have 2 over 1 times k minus 10 over 2. You can see the pattern. There we go. 1 times k minus 10 is k minus 10. Okay? 1 times 1 is 1. But you know we don't need that 1 at the bottom. If we bring down the rest of what we have, we get negative 14 on this side. And what we just did was create a one-step problem. So, get k by itself, we now add. Notice we did things kind of backwards. There it is. K canceled out. Negative 4 plus 10, negative 4. K equals negative 4. We'll try one more of those. Here we go. Looking at number 8. 9 plus m divided by 3 equals 2. Okay? Now, this time with funky fractions, we cannot do this first. Can't do it. Okay? So we cannot add or subtract first. We have to divide out the 3, or multiply out the 3. 9 plus m divided by 3, that's a multiplication problem, or a division problem, so we will now multiply the 3 out. Times 3 on this side. Right? You know, long story short, this is going to leave us 9 plus m. 2 times 3 is 6. Okay? So now, to get m by itself, you'll subtract 9. Subtract 9. That leaves us m. 6 minus 9. Make things more complicated than it is. I subtract, I'm going to have a negative 3. So, m equals negative 3. There we go. Okay? So those are examples of two-step equations, right? We'll do one more, just because we're on a roll. And this time I'm going to go back to a multiplying one. Like number 22. This is a multiplying example. We're going back to add or subtract first. So which means I'm going to add 7 here, add 7 here. That cancels out, giving me 4r. Negative 15 plus 7, 7, 8, 9, 10, 11, 12, 13, 14, 15, that's 8. It's going to be negative 8. I now created a one-step equation. I'm going to divide by 4 on both sides. That cancels out, leaving r. And this will be negative 2. R is negative 2. Okay, so that's good practice of two-step equations. And hopefully during class we'll be able to get to multi-step equations. You're going to love these. I'm telling you, you're totally going to love it. Alright, so multi-step equations look like this. And it's really everything that you've already learned how to do. Just kind of put them all together into one type of problem. Okay? Look at what you have. Take a look at what's different. Multi-step means you're not going to just do one thing to get the letter by itself, not just two things, but you're going to do three things or more. So multi-step equations mean you're going to do three things or more to get the letter by itself, right? So check this out. Doesn't this look familiar? That's right, need to distribute. Okay? So with this type of problem, we'll distribute first. I have 3 times 1, that's 3. 3 times negative 9r will give me negative 27r. Let's bring down everything else like we see it. There. Okay? So now, the thing is that we have to combine like terms. But combining like terms here is a little bit different. We draw our street. Notice you have r on both sides of the street. You got to put r on one side of the street because that's how we solve these equations, right? So you're going to move one of them, okay? Find the easiest one to move, which is usually the smaller number, right? And that means I'm going to move this negative 4r, okay? I'm going to move it by doing the opposite of what I see, just like what we do normally. What you do to one side street, you have to do the other, and it has to be the opposite. So I'm going to add 4r here and add 4r here. There it is, okay? So now what I'm going to do is bring down what I have left. If I do that, I have negative 43, that cancels out, equals 3, negative 27 plus 4, right? It's going to give me, what is that? 3, so 4 to 5 to 6 to 7, yep. It's going to give me negative 23r. Okay, so check out what you just did. You just created a two-step equation that you should now be used to. R is now just over here by itself. So remember, you're going to do the adding or subtracting part first, which means you need to get rid of this. Okay? That is a positive 3, so I will now subtract 3 from both sides. Subtract 3 here, subtract 3 here. Okay, so now I have negative 43 minus 3. That's going to give me negative 46. That canceled out, negative 23. You now will divide by negative 23, divide by negative 23. And I think this should be 2. Let's find out. 46 divided by 23, 2. And it's going to be a positive 2, right, equals r. 2 equals r. Okay? So I'm going to do that one more time. Still one more time. Got this. Let me get all this out of the way. Just to give it more space. So we'll try to see things clearer. Okay, here we go. All right. First thing we're going to do is distribute. Three times 1 is 3. 3 times negative 9r is going to give us negative 27r. So that part is done. We bring down everything else. Negative 43, right? Now, we set up our street. What's new is that we have r on both sides of the street, okay? R can only be on one side of the street. So we're going to have to, sorry about that, we're going to have to move one of the r's over to the other side of the street. Typically, it really doesn't matter which r you choose to move. You could choose to move this one, you could choose to move this one, right? But I always like to move the one I think is going to be the easiest to move. And to me, that negative 4r is going to be the easiest to move. Because I see negative 4r, remember, to move something across the street, you have to do the opposite of what you see. Excuse me. Negative 4r means I'm going to add 4r to both sides. Add 4r to both sides. When I do that, negative 43 is still here. That canceled out. Bring my 3 down. Now I have negative 27 plus 4. Okay? So when I have negative 20 plus 4, that should give me a negative 23r. There it is. You see 24, 25, 26, 27. Yep. Negative 3r. So now, what you basically have is a two-step equation. It's like we just practiced on the other sheet. R is still not by itself, right? You know that this means multiply. Don't start there. Don't start there. You have to start by removing the positive 3. And how we move the positive 3, do the opposite of what we see. On this side, negative 43 minus 3 is going to give me negative 46. That cancels out, and I have negative 23r on this side. Notice you just knocked it down to a one-step equation. To get r by itself, you must divide negative 23 on both sides. Okay? When we do that, negative 46 divided by negative 23 gives us a positive 2. That cancels out, leaving r. So 2 equals r. There it is. Let's practice another one of those. All right. Let's take a look at number 2. Number 2, I'm just going to rewrite up here. I have negative 2. Start there. Start down here. I'm doing number 2. Here. Okay. So I have negative 2 minus 9m minus 2 minus 1 equals 27 plus 10m. All right. First, distribute. Negative 2 times a negative 9 gives me positive 18m. Negative 2 times a negative 2 gives me a positive 4. I'm going to bring down that minus 1. That takes care of this side. Equals 27 plus 10m. All right. Here we are now. We're going to combine like terms. Ooh, we got a couple of stuff to combine here. Okay. You notice you have this, you have this, but they're on opposite sides of the street. Okay. So that means you have to move one of them to the other side. You can move this one over here, or you can move this one over here. Your choice. I tend to look at what's going to be easier for me to move, because remember, you have to do the opposite of what you see, right? So you see a positive 18, you could minus 18 on both sides. Minus 18 on both sides, right? So we can do that, or we can minus 10 from this side. Minus 10 from this side. This one is easier for me to do because it doesn't really have any funky, integer rules, whichever. It's just 18 minus 10. You know that's going to give me a positive 8m. So I cancel that out, right? Bring down what's left. Because remember, you just canceled this out. Now, here's the thing with this one. You still have terms that you can combine. Going back to what we previously learned, you have a positive 4 and a negative 1. Positive 4 plus negative 1 means we're going to subtract, keep the sign of the higher digit. We're going to have a positive 3. Let's bring everything else back down. All right. Now, what basically just happened is you created a two-step equation. Look at what you have. That's a regular two-step equation that we have practiced before, right? So, we know what to do. We've got to get m by itself. You start with the adding or subtracting first. That leaves us 8m. 27 minus 3 gives us 24. M is still not by itself. So we'll divide by 8. Divide by 8. M equals 8 goes into 24 3 times. M equals 3. Right? You're going to have to go back and rewind on that one to see how to do it again. I'm going to try one more because I know that these are brand new and hopefully they're not scaring you, but remember, we're still going to do them all in class. Okay, so this time I'll go to an easier one. Let's do number 3. That's 28, right? 28x, you know, I just can't. 7 times 4, 28, right? Oh, look at that, I learned. Bring everything else back down the way I see it. Here we are. I'll draw my street. Notice you have like terms to combine, right? You can start with the x's. Oh, the x's. See this? You see this, right? You gotta combine them. So that means either 7x or 28x needs to move to the other side of the street. Again, move the one that looks like it's going to be easier to move, right? Because you have to do the opposite of what you see. So to me, it's easier to move the 7x because all I have to do is subtract 7x. Subtract 7x. So when I do that, I now have 49. That canceled out. 7 plus... Okay, so now you have 28 minus 7. You know that's going to give you 21. X. So you just combine the like terms and simplify that part over there. Okay? So what happened is you basically just made it to a two-step equation. Take a look. X isn't by itself. You got to do 2 things to get rid of the numbers that are with X. You got to get rid of this, and you got to get rid of this. Remember, you have to do the adding or subtracting part first. So that means I'm going to subtract 7 on both sides here. Right? This gives me 42. That canceled out. 21x. X is still not by itself. You know that this means multiply, so you will do the opposite, which is divide. Divide out that 21. 42 divided by 21 should give me 2. That cancels out, leaving x. 2 equals x for that one. All right. Well, of course, we're going to do a lot of these in class. Don't worry, my friends. I got your back. And if I need to add more to the video, you know me. I'll just add more to the video. We create a part 2 according to how well we do in class, okay? Let's see what else I had. A couple of things else that I wanted to show you or to make sure that we understood. The enrichment that I put for this week's work is an equation review. That includes everything that we just did with the 1-step, the 2-step, and the 1-step, 2-step, that's funny, and the multi-step. So, and combining like terms and distributive property. So this is like a big review of everything that we've done that has to do with the algebra part. Not anything with fractions, but just with the algebra part of what we've been learning. So no fractions, no decimals, just the algebra part of what we've been learning so far. So this is a big compilation of everything put together in one set of worksheets, okay? So I took some problems that you would find exactly in the GED book, and I just made it into our own worksheet. So I would really practice these. So I will point them out in class, and we'll do a few of these in class, but most of them, you can do on your own, and you can hit me up for tutoring or something like that, right? So let's see, what else? Oh, so, and then I have, yep, we just did that. And remember I said that we would go back to the adding of fractions, right? We're going to do some of those in class, but I also want to point out, I'm not going to put any of these on video right now because they're already in the classroom, right? So if you go on to the 28th, the work from last week, looking at the first video, adding somewhere around here, the same problems. Somewhere in here. There we go. There we go. So you see the video is already here for the adding and subtracting fractions, right? The video is already there for those. So I won't put that on the video here because this video is already an hour long. So these are already taken care of on video. Just remember on the 28th, they're already there. This one and this one are already taken care of, but we will do some of those in class. Okay? So that takes care of our video for tonight. And thank you very much. Tuesday morning class, I will see you in like less than 12 hours. And then Tuesday evening class, you got a little bit more time to practice ahead of time if you would like. All right, see you guys later.